Yeah, so the review had some word problems. Section 7.6 is going to be word problems. Yeah, so it's just going to show up in a lot of different sections. Yeah.
So you don't do sections per day. You just kind of do the whole chapter 7, and then you.
No, I do sections. Yeah, right now word problems is just kind of like lives in every section. Yeah. No, the group work you keep. Some group work I'm going to have you turn in. Sometimes I trick you. I put your name on there just so you're nice and neat for yourself, right? If you know you're not going to turn it in, sometimes it's just all over the damn place. Okay, I trick you into being nice to yourself. So let's do a word problem right out of the book here. Let's see. Let me get a good one here. We did those. Let's do. There we go. Perfect. All right, so this is if you have the book with you. It's on page, let's see, do I want to do these? Sure, page 355. One from here. Oh wait, this is not what I want. Let's see. Chapter 6. Yeah, okay. Let's do this instead. I'm sorry. Page 415 instead. We'll do it live. All right. Put that in the area where you can see it. Ooh, it's got these. All right, I like this one. Number 105. Aha. All right. So, I need you to understand something. My pre-calculus students, my calculus students, probably my Calc 3 students I'm going to have, they all suffer from the same problem when it comes to word problems, setting them up. Right? So I don't care what level of math you're at, you never leave this, because instead of word problems, you just call this using math in the freaking real world. Right? I mean, that's the step we want to take. I want to be able to do the process, but then I want to have a real world situation and know how to use math. The higher up in math you get, the more real the problem can be. Because the real world is messy. So I need higher level math to measure that, to model that messiness. So we can't get overly messy here, but it's messy enough. So looking at that problem 105.
What page is it?
Page 415. I changed my mind on the first time. So the first thing you do when you see a word problem is you don't think about math at all. You think about English. What are the players in this problem? What are the parts of this problem? What's involved? Rectangle, I think. What about the rectangle? Be more specific. No. See, that's a number. It's math. I'm talking about names. What about the rectangle? The length and the width. I like it. So the players in this problem are length and width.
I chose width to be X.
Alright, and the next step, after you figure out the player, so it could be a triangle where you got 3 angles, maybe the largest angle, the smallest angle, and the other angle, right? You use the same words the problem does. You don't call them angle ABC. You call them largest, smallest, whatever the problem, because then you can always see the connection, where it come from. The next thing, like Nathan said, is now I want to go from English to math. And that's why math is difficult, is because it is learning a foreign language, and that's not easy. So the floor is 7 feet longer than it is wide. So which one of those do I have to start with? Which one would I have to know first before I can figure out the other one? How wide it is. So that's what so I have to know. If I knew it was 5 feet wide, how long would it be?
7 feet long.
Good. So if I knew it was 5 feet wide, it would be 12 feet long. Because how is it 7 feet longer than it is wide, right? So if it was 10 feet wide, it would be 17 feet long. What's that? So it says it's 7 feet longer than it is wide. Bam. So if it was 20 feet wide, it would be 27 feet long. Do you guys see that? 7 feet longer than it is wide. So how wide is it? Good. I don't know. But whatever this is, what do I do to it to get the length? Add 7. I like it. The people that skip this step are the people that skip that. All they do is they see 7 feet. Okay, 7 feet longer, and that's going to be equal to 120. Yeah, that's crap, right? That's saying that that one side is 120 square feet, which is another problem. Right? You forget that there's multiple parts to it, so you want to capture all the parts to it. I don't know if that makes sense. So don't focus on math first. Your first thing is English. Just what are the players? Then you translate to math. Cool. Now, what are these supposed to do together? What's the rest of the problem now?
Length times width equals.
Yeah, the area is 120. So the area, so if I draw myself a little picture, the area, of course, is length times width, so the area is x times x plus 7, and they tell me that that area is 120. So you can draw a picture, figure out the parts of the problem in English, write those things in Mathish. The most important step is figuring out who is just x, because then everything else gets built off of that. And now how the hell do I solve this?
Do you factor the x into the parentheses?
Multiply it in, yeah. Distribute that x.
Yeah, x squared. So x squared plus 7x?
Because see how this is a problem? If only that was what, I could actually just solve it directly. If only that was a 0, and it's a freaking 120. So somebody factored this without this being 0, so I got to bring that 120 over. So if I unfactor this, now I can do what?
Minus 120?
Minus 120, so I can make it equal to 0. Now should be the easy step. Try to finish that out. This one's not one that just jumps out at you, right? So what I would do, so some of you guys, it's not the first way I think to factor 120. The answer here, right? Who's got it already? Good, 8 and 15. So what I would do instead, and that's if somebody said factor 120, I wouldn't just go, yeah, it's 15 times 10. That's the last thing I would think about. I'd say it's 12 times 10, 6 times 20. You guys kind of with me? So what I would do, I think I talked to you about this before, I don't have to start with that. I can make things that make 7, that are different signs. So for example, like negative 17 and 10, don't they add to be, 17 and negative 10, don't they add to be 7? Mm-hmm. But what do they multiply to be? 170. So that's too much. You guys got with me? So it becomes that Price is Right kind of game. So then I can make this 15 and negative 8. Sure enough, that's negative 120. Kick ass. So you could do that if you want to, or you could just list a lot of factors of 120 until you hit the right ones. Maybe. Let me show you something else. if you first think about 12 and 10 here, right? Break it all the way down. Break it to like 3 times 4 times 5 times 2. 3 times 2 times 2 times 5 times 2. Now reorganize this. So what do I mean by that? I mean like this is 20 and 6. Do you see that? If you, what's 2 times 2 times 5? 20. Times 6 is also 120. Or you can put them back together in a different way. So you can just kind of reorganize the factors. So you can break it down to its DNA and then put the DNA back together in different ways. Play God with the numbers. Again, if you don't like that method, I'm not saying do it this way. Some people like this. Some of you guys maybe never seen this before and you're like, holy shit, that makes sense. Beautiful, do it that way. If some of you guys are looking like you are right now, like, what the hell's that shit? Well, then never do it that way. Right? Do it the way that makes sense. But I'm going to show you different ways because different things make sense to different people. Alright, so either way you do it, you should come out to be 15 and negative 8. So the next is negative 15, or x is, considering this is a physical reality problem, we're trying to construct this, what was it? I forgot already. Shed. I'm trying to make this shed. Which one of these do I throw out? Yes, please do God. Don't tell me you're going to make this negative 15 foot long shed. I'm like, what material is that? What is that? Black hole material. Don't get too close. You know, no. Throw that out. So x is 8. What's? Feet. So that is the width. What's the length then? 15. Exactly, 15 is another. Now notice, negative 15 makes mathematical sense, because that would be negative 15 and that would be negative 8, and they multiply to be 120. But we go, okay, math, you're a little drunk, you need to go home. Can't have a negative side, so we just throw the negatives out. Yes?
I know that that's the shorter way, but where you were doing it with the x plus 7 equals 120 on your far left, but then I also do the x plus 7 equals y, and then on the bottom x plus y equals 120.
No, nothing adds to be 120 here, because 120 is an area. So you have to have something times something to make 120. Right? Length times width to make the area.
Well, right, but then like do the
So you could say x times y is 120. Sure. And then you can say y is x plus 7. Sure. And then you can plug that in, and you end up where we got.
Right.
Totally. Kick ass. So you can use 2 variables more often than I do. I just don't like using 2 variables if I don't need to. Yes.
So automatically you just throw the negative out to 15 even though it's a negative.
Exactly, because we're talking about lengths of the shed, right? So the negative thing is a little freaky.
It wouldn't make any sense.
Wouldn't make any sense. Doesn't make physical sense. So the math gives us the numbers that work for the equation we wrote. We know this equation models something in the real world. So we're going to throw out the numbers that work that don't make physical sense.
And that's not always just because it's pertaining to this equation?
Just because it's talking about the shed. Now, if this is profit of a company, unfortunately, that could be true. You can have a negative 15,000 profit because you lost $15,000. But I can't have a negative 15 side length of a shed, right? Again, I'm trying to imagine what that would be. I'm not sure. All right. So what's important here is not anything specific about this problem. It's what are the steps in any word problem. Draw a picture if it makes sense. If the problem is about a bunch of people, don't draw a bunch of people. Unless you really don't know and you're just like, we just doodle. If it's geometric or something, draw the picture so you can label it. In English, who are the players? Who's just X? Build the other ones. And then, what are they supposed to do with each other? Is it a total? Do you add them all up? Is it an area so you multiply them? Is it a perimeter? Which would suck for this because people make a lot of mistakes with perimeters. So if I said the same problem, but I said the perimeter was, let's see, 54 feet. Let's see if you guys can handle this. So now I'm making a new problem, but I have the same setup. What would my equation look like? So the length is still 7 more than the width.
2x plus...
I love it. So the people that do this, that's no good. Because how many sides did they build? They built one side. Right? They built this side. The people that do this, still no good. If I put my little orc in here that I caught, little orc, he's just going to walk away. I didn't put the others. Oops.
Would you do 4x plus 14?
Yeah, totally. So I've got to do an x and an x plus 7 and another x and another x plus 7. So I go all the way around. So then you get 4x plus 14. And then you can solve that. So if it was a perimeter problem, I have to take all the sides into account. Area problem, of course, we have to use an area formula. I like it. This was the easiest area formula, like times width. Okay. So let me give you this handout. My most colorful handout yet.
So that one has a remainder.
What's up?
So that problem has a remainder.
No, it should work out nice. X should be 10. What do you mean a remainder?
Well, the original problem was 120. Oh, never mind. That was the first way I did the problem.
All right. So what I'm hoping is, as you do the assignment, you can have this sitting next to you so you can reference, and I'm hoping this makes some sense. I've given you some steps. The steps, what are the players? So in this problem, it's a triangle, it's perimeter. So I'm going to use the exact same language. I have a largest side, I have a shortest side, and I have a middle side. So, of course, why would I make the shortest side be x? Why would the shortest side be just x? Well, I told you. Because the other two depend on it, right? So, the largest side is 3 times the shortest, and the middle side is 1 less than twice. So, I've got to know what the shortest is first. Now, the most evil word in English is less than, right? The most evil phrase. Because if I just ask you, what's 3 less than 10? What's 3 less than 10? 7. You didn't just do 3 minus 10, did you? You did 10 minus 3. Oh shit. So math has to handle the horrible grammar of English and make sure that it makes sense mathematically. I'm putting all the onus on English. I wonder why. I might be a little biased. So when it says 1 less than twice the shortest, it's 1 less than twice. It's 2x minus 1, not 1 minus 2x. When you do that, you get the weird-ass negative length triangles. Right? Which again, I don't know what the hell that would be. Do you guys understand what I'm saying? That's the hard. That phrase is the only one where you got to turn the things around because English grammar means that. And math goes, oh, you mean this? Oh shit. So I give each of these a math name. Bless you.
Yes, ma'am.
Someday I'll be able to real explain so everybody understands. Right now, this represents an infinite number of triangles because whatever x is, whatever x you pick. Then I'm going to get side lengths for these, right? So if I let x be 10, this would be 30, and this would be 19, for example. Are you with me? Mm-hmm. So when I set up the equation, I want to force it to come out to be 23. So when I solve, I'm going to see what value of x would make that triangle happen. So this step is just saying, what would any triangle look like whose sides were related like this? And then when I set up the equation, I say, I want the triangle that makes it 23. And that's what those two steps do together. English, mathish, equation, and when I solve it, I get what x has to be to make my triangle happen. Right? I don't know if that makes sense. All right. So to break it down more practically for you, these are the steps to follow. The people that don't follow these steps, you'll get some of them right, but you'll make some really dumb mistakes also. Right? So my point is, you're not going to save time by having to redo the homework when you make all these mistakes. So here's another kind of problem. There were 3 more than twice as many women than men. Now that's kind of an evil phrase too. Who were there more of?
Women.
Who were there more of? There's 3 more than twice as many women than men. Who were there more of?
Women.
Women. There were more women there. If there were 8 men, how many women would there have been?
19.
Yeah, you would do twice. What does it say? 8? Twice 8 plus 3. Yeah, so 19. I like it. You guys get what I'm saying? So that's why. Who do I have to know first? The number of. Who do I have to know first?
Women.
The number of men, like we just did. So that's why I let the number of men be X, and the number of women would then be 3 more than twice. And what do these have to do together? Well, there were a total of 363, so they got to add to be 363. I like it. So that's how you take it. You attack it. Who are the parts? What are the parts of the problem? Give them math names. Then you step back and say, what do those parts do together? Do they add? Do they multiply? That's where the equation comes from. And then that should be the easy step now. Solve the equation. That should be the easy step. So you guys take a minute. You can work together or not. It's up to you. Do these 4 problems. I started you off really nice. This is what's called pseudo math. This is 1 step away from an equation, really. Oh, shites. You won't see any of that.